All right, welcome back to another week of hobby kernel development. This is week 28, and today we're doing interrupts, which I am frankly terrified of because I actually really don't know that much about this, and so it's possible that we're going to run into some things I don't know how to do. I'm also experimenting with a bit of a different camera angle today. Yeah, but let's get into it. So basically I've been working on getting user space working, and that's kind of working, but then like there's no system calls or interrupts at all right now. And so that's what I'm trying to do. And basically, I'm just going through this MIT class, and we're now at exercise 4. So I haven't totally read through all of this previous stuff. I probably will need to at some point, but just for the moment, I'm going to, just check out what actually I need to be doing today. So edit trap.s and trap.c and implement the features above. Macros. Yo, Afnan, what's up? Test 3. Nice to see you, Afnan. Hope you're having a great day. These macros should help you as well as these other defines. Just a new camera angle. That's it. I'm trying something new. Yeah, because I was seeing all these other streamers on YouTube, and a lot of them have this like sideways view. So I'm trying that today. Yeah, open to feedback about that. Curious what people think. So you'll need to add an entry point. Using those macros for each trap defined, and you'll have to provide all traps. Nice angle though, much better. All right, cool that you dig that. Maybe I'll keep doing this in the future. Like I have my like phone set up like on this tripod thing right next to me. But all traps. Okay, don't really know what that is. You also need to modify trap init to initialize the IDT to point to each of these entry points defined in trap.s. Set, oh man, okay, this is easily, I think, going to be one of the hardest things I've ever done on stream. I really feel so out of my league with this. Your all traps should push values that make the stack look like a struct trap frame. Load GDKD into DS and ES. Push along ESP to pass a pointer to the trap frame as an argument to trap. Call trap. Easily going to be the hardest. Yeah. Man, I'm quivering reading all this stuff. Frankly, I don't even know what any of this means, really, at this point. Consider using the push AL instruction. It fits nicely with the layout. So I think we're going to be writing assembly today, which is terrifying. Okay. Test your trap handling code using some of the test programs in the user directory that cause exceptions before making any system calls. Okay. You should be able to make, okay, whatever. Okay. Wow, okay, that's a lot. Let's check my Git is kind of clean right now. I just have these comments that comment out these like random unit test things that I was using previously. And where do I even begin? I'm just going to close all of these files. Okay, and get, so init.c, for example, has this place called trap init. So there's trap.c, which I have never seen before in my life. Print trap frame, trap dispatch, trap. Just checking on the audio to make sure everything's working. All right, cool. So there's already a lot of stuff. There's already a lot of stuff here. Trap name. Oops. Yeah. Trap entry. Okay. Wow. Can I not get syntax highlighting? Is there like x86 or okay? I guess we're going no syntax highlighting for the assembly. Exceptions and interrupts. Lab 3. Your code for generating entry points for the different traps. Your code here for all traps. Jump to all traps. Interesting. So, okay, so all traps is, I think, some kind of assembly routine that it's kind of like some kind of core like handler, and we're going to generate a bunch of these like little stubs or something like that that just push a small amount of data and then jump to all traps. Yo, Handle, what's up? Nice to see you. Trap handler no EC, no error code or something. Trap handler defines a globally visible function for handling a trap. It pushes a trap number onto the stack, then jumps to all traps. Use it for traps where the CPU automatically pushes an error code. You shouldn't call a trap handler function from C, but you may need to declare one in C, for instance, to get a function pointer. Wow. Okay. Wow. All right, guys, this is a lot. I still don't quite know where to start. It is just, yeah, it's like a initialize and load the per CPU TSS and IDT. Okay. This is crazy stuff. This is really crazy stuff. Guess I need to read this. Yo, Plebish, what's up? Wow. I think I need to read through this actually. This is kind of crazy. So today we're doing interrupts because last time we finished this thing and now we're trying to handle int hex 30 instructions from user space. But in order to do that, we need to just handle interrupts in general. So blah, 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 blah. Interrupts are like from hardware, or usually exceptions are more internally generated by software. The IDT. To implement edit trap.s and trap.c, right? That's what I've been looking at. Apparently, okay, I'm just gonna grep for all the lab 3. Wow. That has so many places. Okay. Okay, I think that was not a good idea. That's like showing me way too much stuff. Also, it's showing all these places that I've kind of already worked on. Okay, yeah, this is a lot of this stuff is not relevant for me right now. I still don't get what code. So here's a place I might need to write code. Your code here for generating entry points. So here I'm going to be calling trap handler. Okay. Can I do? I don't even know how to do a comment in. Is a hash a comment character? Weird. Okay. Call trap macros. Then I need to implement this assembly function, all traps. And frankly, I don't really even know how to do that. Define global symbol. So I need to write an assembly function. Okay. So I'm going to just get my working space. So I need to trap.c, trap entry.s. So what do I need to do? I need to do something here. Then I need to use macros to declare handlers for specific interrupts, implement in all traps. As well as the T defines. What are the T defines? Trap.8 or what? Trap.h. Okay, so we got some trap numbers. Okay. Question, can we can include those files from our assembly file. For each trap defined, and okay, so they tell us what to do. We need to add an entry point in trap.s for each trap defined. You will also need to modify trap init to, okay. I'm just going to start, I was also kind of going into their class materials, which actually was pretty handy. So they gave me, so far I've been able to do all of this without really looking at the lecture notes, but we're getting into territories where I really don't know anything. So yeah, although honestly I'm not sure how these are how helpful these really are. Yeah, it's a good, yeah. Yeah, I guess this is why you actually take the class and not just try to do this on your own live on YouTube without having taken the class. So So here are a bunch of the interrupts and or exceptions and or traps. Oh, interesting. Which is actually super useful. So maybe I'll just take a baby step to start. Maybe we can try to handle the divide error. Wow, there's so many. Divide error. I'm just going to try to wing this. So it says divide error, error code no. Which means I'm going to call trap handler no EC. What that I call? I pass in a name and a number. Like for example, like that divide error T divide. I truly have no idea what I'm doing. Do I need a semicolon at the end? Okay, the first thing I'm going to do is trigger a compile error, just to even see if this compiles. Error, no such instruction, blah blah. So that's a good sign. Yo, what up, Right Way Gaming? Bro, can you hack an account by phone number? No, sorry, dude. I cannot hack an account, by phone number. Okay, so that means it's compiling. I'm just gonna clean this up. Undefined reference to all traps, good. So, but what if I even comment this out? So now it compiles. Okay, good. So I officially am emitting a bunch of code, and I kind of wonder actually if I can look at it in my build output kernel trap entry .o, right? Looks like kernel.asm. Seriously? There's literally a file called kernel.asm. How? Okay, that's why. Okay. Yeah, but thank you for asking. Yeah, I'm flattered that you would ask, but no. Okay. Whatever. So good. And I kind of don't know what to do. Do I do like global traps? I'm just gonna do like a halt. I don't know. Is that? I don't really even know if that's an instruction. I think halt is an instruction. So that actually did compile. If I commented that out, does it not compile, or does it? It still compiles. So. So I don't know. Okay, going back. Going back here. To initialize the IDT to point to each of these entry points. The set defined in trap.s. So the IDT, I should probably know what the IDT is before I continue. I have a vague understanding that it's an array or something of these IDT descriptors, which look something like this. Yeah, no, I need to get a better understanding of this stuff. Use a vector into the process interrupt descriptor table, which the kernel sets up in memory from the appropriate entry in the table. So do I have like, is there, says GDT. Hey Ismail. Actually, no, just a different camera angle. I'm just trying out a different camera angle today, inspired by some of the other YouTube streamers that I've seen. So just a different angle. Why does it say GDT? Okay, yeah, no, what? Okay. Per CPU setup. Okay, right, so here's gate. Okay. Slowly uncovering what exactly I need to do. Yeah, I'm also trying to make sure I'm not hiding the code with my video feed. Yeah, so here's where we trap.c. Okay, we just have some global variables. Okay, gate desk is the type. So here's the IDT. Simply put, here's the IDT. IDT PD. Time to learn what so gate descriptor. It's like the descriptor inside the IDT. Let's see if this matches up with what the documentation kind of says. How do you even read this? Is it 32 bits? Wow. It's real beginner hours. Yo, Siddharth, what's up, man? Cracked low-level devs have been rare nowadays. I mean, I'll just be honest with you, I am so not cracked. As you will see if you keep watching, I have no idea what I'm doing. IDT is this array of these descriptors. Inside the descriptor is a pointer to these stubs. And then they call trap, which is somehow in C. each of the handlers. Right. That's kind of what something was saying. Each of the handlers should build a struct trap frame. Is that what this okay, now I'm getting a bit lost. Oh yeah. Okay, I'm just gonna copy this in here just for reference. Push right. So all traps is an implementation detail, and at some point I don't really know, I'm just gonna copy these into here. Oops. Okay. Push values to the stack. Load GD KD. Push LESP. Okay, is that easy or what? Push LESP. Call trap. Okay. That's me kind of sketching out what this is going to look like. I still have no idea if it's right. I'm gonna try to build it though. Okay, it still compiles, but then if I say like blah, it should not compile, right? Okay, good, doesn't compile. Call trap. And trap is like this C function. That takes a pointer to a trap frame, I see. And that's what we do here. This is how we pass that pointer. We push everything onto the stack and then pass a pointer to the stack, to the C function, to pass the trap frame, I see. Understood, okay. Yeah, Ismail, we're doing some assembly today. Like, yeah, I've never really had to write assembly for this kernel yet. I've been lucky, because the base foundation provided all of it. And truly, I don't really know how to write assembly. Like I kind of don't even know what this is and stuff. I just know a few things, but hopefully I can figure it out. Like I don't, yeah, well, how do you load? How do you load? I mean, that's kind of probably a very simple thing to do, but how do you load into one of these registers? Ah, but what is this? You use a move. Ah, interesting. And they already do this. I guess I never really needed to learn about this function yet. Env init per CPU. Also, what's a pseudo descriptor? Pseudo descriptors used for the LGT. Oh. Interesting. It's like, yeah. Limit and base. Okay. Kind of don't understand what that does yet. Project is a great learning experience. Yeah, absolutely. Like even right now, I don't know what I'm doing, but this would be 100 times harder if I had to do this purely from scratch. I feel like at least I have a bunch of code existing where I can kind of copy and stuff from. Okay, but this is kind of important. So apparently, Let me just take a look at who. So we have a single caller, and this caller is part of env init, which is initializing like our array of our environment structures. But then we do this random per CPU initialization, which I'm now reading, which it's very interesting that it loads. I guess each CPU needs to load the GDT. I thought we already did that, but I have no idea what I'm doing, so whatever. So, and then they do a bunch of stuff. Kernel, oh, KD is kernel data, KT is kernel text, maybe? Global descriptor numbers. Wow, yeah, I am feeling very out of my league. How is this used? So here is where we set up our GDT. It's an array of the GDT descriptors, which are called segment descriptors here in this code base. And first is always null, because that's just what you do. And then we have 5 entries in the global descriptor table. And then, so these just like the global descriptor table is static and does not change dynamically during runtime, basically. So this is all just statically set up with these 5 entries. And then at runtime, we can alter the segment registers and point them, and point a segment register at different descriptors, different entries into this array, which then makes references using that segment register reference this like descriptor entry. I don't really get how that pertains to handling interrupts, to be honest. That's more of just like it's just like a memory thing. Like this is like the alternative to paged virtual memory. It's like the old school segmentation memory, but whatever. Those are details. So we have these like 5 entries, and I guess they're ordered. I'm not quite sure why these specific numbers were chosen. 8. It's like 8 shifted to the right 3 bits. Which is just 1 or something, or okay, maybe I won't think about that too hard right now. Anyway, and then we have a TSS entry, which we need to actually initialize. So what I said before was kind of wrong, I guess. We actually will mutate the GDT to initialize it. So I'm just going to take a screenshot of this and put it over here. I'm just going to take screenshots of a lot of things. You know, this is maybe something kind of odd that I do, but I'm a big fan of taking screenshots of code when I work, because there's like, especially when you're working with a big code base, and this is not a big code base. this is not a big code base, but even with a medium or even code base, you're going to have a ton of stuff all over the place that might be helpful to just have a single view of. Yo, what's up, Ethernet? Watching this while I write JavaScript. Hell yeah. Okay, so RDT, and what else can I take screenshots of? So we have all this stuff. Just to kind of get oriented in a bit of a, yeah, a bit more oriented here. This was an env.c. Yeah. This is trap.c, trap.c, trap assembly. Okay. All right. Ethernet, what are you coding? JavaScript, some kind of web app or something like that? All right. But anyway, back to, it was saying I need, so back to here. Oh, I think now I understand why we have the GTT, because we need to actually mutate this. But it actually already does it. It already does the mutation. The per CPU TSS. So apparently there's something per CPU. I don't really get this per CPU stuff. TSS and IDT. What is TS? Task state. It's a static. So we're just initializing a bunch of these descriptor registers. We have this task state thing, which I don't really know what it is, but it's like this big, oh, I think it's like the actual task state segment, like period. This is the task state segment. And so when we have this TSS entry, this TSS entry in the GDT is going to point to the actual TSS, which is this thing, okay? And apparently, I still don't understand the per CPU nature of this, but we set some fields in there for some reason at this point. Then we initialize these TSS descriptor slots in the GDT and just checking GDT TSS 0 shifted 3 is exactly what we have here. And then load the TSS selector, load task register, or something like this, with the descriptor. Now that we have the entry in place, we can load this. Yeah, I don't know. These are like really obscure details. Load this entry with the descriptor here, and then apparently we can finally load the IDT. So I am curious about this set gate. I'm kind of going all over the place here, but yeah. Hey, Miami. Hello, hope you're doing well. Yeah. All right, is anyone else working on any cool projects lately? Just curious. Yeah, feel free to share. To initialize the DT to points each of these entry points. So I'm just starting off super basic with my divide handler. And maybe I'll just try to get that working and not worry about any of these other traps or interrupts or exceptions. So what's the set gate macro? Set up a normal interrupt trap gate descriptor. Wow. So I would like to look up what this structure actually looks like. So I had this thing that they gave me, but yeah. So I'm also going to screenshot this from the manual as a secondary reference. So is it the same as what they have? Looks pretty similar. I think it's the 32-bit entry. But yeah, I need to understand this a bit better. The IDT may contain any of 3 kinds of gate descriptors. Shows the format. The task, same as that of a task gate used in the GTT. I don't think that's what I'm doing right now, though. I think what we're using is an interrupt gate or a trap gate, or what? Yeah, we're not using a task gate. There's a reason what to call gates. Who knows what is a call gate? A far pointer to a handler procedure in an exception or interrupt handler code segment. They differ in the way the processor handles the IF flag. Okay. Is it just me, or is it very confusing what this diagram is trying to express? I'm like, does it start from here? Is this bit 0, and then is the 4 meaning it's like offset 4 bytes? That's my guess. So we have like a 32-bit structure. Oh, this is interesting actually. So maybe this is like a remnant of like 16-bit compatibility or something like that. Okay, so we have like this, what is the offset into the segment? I see. So we have a 32-bit offset, which I guess makes sense. We have a segment selector, and we have a ton of flags or I don't know. We have a present bit, we have a privilege 2 bits, and apparently these are all like hard-coded or something. So yeah, okay, that's interesting. So now let's like cross-reference this against the macro. So interesting. So now it's like you pass in a gate, which is going to be one of these. It's not a seg desk, but it's like a. Oh shit. It's not here. It's where's my IDT symbol? There it is. It's a gate desk, right? So when we look at this macro, I'm just gonna I'm gonna kill this. All right, we have this set gate. We have this macro, and I'm actually kind of wondering why it's a macro, even in the first place. Why isn't it just a function? But basically, it's operating. You pass it in a gate thing, and then it starts to mutate. These are the members, and that's why we can see this correspondence here. So, what is is trap? Oh, that's a Boolean. Okay, I didn't know how to read this. Like I strap is trap. It's a Boolean, and based on that, it's going to select whether it's a trap gate or an interrupt gate, which are different things. And there is this one specific bit that distinguishes them, apparently. The bit 8 or whatever, bit index 8. Is that what we see here? GD type. Okay, let's like really read this gate descriptor structure to really understand it. I also just realized my break timer has not been running, so I'm going to take a 20-second break. Be right back for standing and stretching. Okay, nice. So my theory was that these things start here at 0, kind of go up in memory from there, building up kind of a 32-bit structure. Okay, can't move this. Oh, wow. What? Okay, whatever. So GD offset 15.0, that's exactly what we see here. So selector 16 bits, GD args 5 bits. GD reserved 3 bits, should be 0, I guess. Then type 4 bits. Interesting. And then the GDS for the 0, that's what we see here in the 12th position. And then the 2 DPL bits and the 1 present bit, and then finally a 16-bit like continuation of this 16-bit offset to build into the 32-bit offset. Okay, very interesting. And I actually guess I didn't really read any of this, but yeah, okay, whatever. Yeah, so we just kind of went through all of this stuff, and basically this is just a bit more of a convenient way to kind of assign all these things, like rather than the caller having to separate out the offset into the two 16-bit parts, they just pass in the whole thing. And this macro does all the masking and shifting. So that's pretty cool. and I'm going to try to figure out how to call this thing. So I'm gonna do my first call of this here. Or what is it called? Trap init, right? So I'm gonna try to set up, or I'm trying to set up the IDT entry for the divide exception. Which I thought was in, oops. So the question is, how do I actually get this gate thing? I know that the divide is like trap number 0. But is the IDT really just, this is not what I'm trying to look at. Search for IDT. I think the IDT is simply maps like an index in the IDT. Yeah. I was just kind of confused because the GDT has that weird thing where the first entry is like always 0, but I think all the synchronous exceptions can generate internally use interrupt vectors between 0 and 31 and therefore map to IDT entries 0 and 31. Okay. So IDT T divide, that's my best guess at how to but that's going to be like copying. Do I need to get a pointer to that? How do you use this macro? Oh, I think, wait a sec, what? This is so strange, like, the IDT entries, so IDT is simply here. It is simply an array, like a very long array. So like, I don't think, anyway, I'll figure that out maybe later. Let me continue on. So is trap, so what's the, like, is this a trap? 1 for a trap equals exception gate, 0 for an interrupt gate. This is not an interrupt gate. This is an exception. It's like a divide. Right, or it's kind of confusing that they say fault here. I also kind of would like to have more of an authoritative reference. Okay, exception class, whatever. So divide error exception. Exception class fault specifically. But I mean, it's kind of confusing that it says interrupt, but I think everything is an interrupt here. Yeah, so user defined interrupts. But anyway, it is specifically an exception. So that means it's a 1. Then the segment selector is code segment selector for interrupt trap handler. This is kind of a guess. Code segment selector. So GDKT is the segment number segment selector for the kernel's text, which is the code, which is text and code are the same thing. Offset. So this is it's like these things, I think. Okay. Divide error. I'm just gonna call it TH. No, that's confusing. Trap handler divide error. Is that 2 verbose? I'm just do this for now. It's just the divide error. I think that. But you may need to declare. So that's what this is talking about. I now need to basically pass this assembly like label or kind of function type of thing here. But how do I actually get a symbol in C to do that? To get a function pointer during IDT setup, you can declare the function with void name, where name is the argument passed to trap handler. So just checking, do we include trap.h? We do. So I feel like trap.h might be where I want to do this stuff. I'll do it. And also it's important to be careful because this header file is shared with assembly, so we can't be using all this random C stuff unless we've declared this. So I think this is where I can start doing this. And just following the instructions. Recently started learning C, got some experience in Rust, and I really like it. Cool, awesome. Sorry, I have no idea how to pronounce your name, but that's awesome that you're trying out C. I would love to try out Rust someday. So I got the divide error, which I'm kind of calling here. What's this push? Oh, is that oh, that's the error code thing. Yeah, that's just the thing in place of the error code. I see. Okay. So now, kind of, I think I can do this. And then lastly is the DPL. For software to invoke, privilege level required. I don't really know. Also, do I have any constants for the DPL? I don't see any. I'm just gonna arbitrarily say that you need, where is this thing? MMU, that's such a weird place. Okay. I'm just gonna arbitrarily say that you need to have ring 0 to call this gate. So in theory, this is sort of what I need, except for this weird thing where I kind of am a little bit confused by how to actually pass in. Because my understanding, or am I just really forgetting how C works? But no, like if you access an array, that's going to copy the entry, I think. So anyway, I'm just going to try to compile this. And it actually does compile, which is suspicious. Let me break it just to make sure. Okay. Now that seems to be broken. So now I'm a little bit unsure. What up, Mangesh? In movies, they do it differently. Just push random button with insane speed. Yep. Yep, that's how they do it in the movies. And they do hacking much faster than I do, because they're much better than me. So how do we move forward with this? I don't think this is doing what I want it to do, but I'm not totally sure. Maybe I can read the assembly. So this is the prologue, and then I'm trying to do my stupid macro. Yeah, that's hard to read. Straight up, that is difficult to read. I guess I can confirm it in a debugger. I guess I can always do that. Yeah, I think that's what I might have to do. Cool. Let me do that. Oh, that might be the fastest way to move forward with this. So now we're at trap init. And can I, oh wow. Wow, this is kind of cool actually. That is actually sick. I can print out, yeah, I can like print out these IDT members and it actually tells me, like it prints it out in kind of a nice way. So now I'm trying to do my stuff. So now that should have done it. And it looks like it actually did work. Yeah, that's awesome. Maybe, I don't know if you can like see this super clearly, but it looks like it worked actually. So because now this entry is actually initialized, which means I just am kind of a C noob because I didn't quite understand why that would work then. Oh, but it's because it's a macro. That's why, because it's not a function. So basically this just generates code that's like IDT t divide like dot blah equals 42 or whatever. That's ultimately what it generates. And yeah, that's going to work because it's just directly, yeah, it's just like accessing that that element, and then you can do stuff with it. That's why. If setGate were a function, I do not believe it would work to call it like this, but that clears it up. So that's what this is, a macro. That's why. Very cool, actually. Yeah, hard to debug. I always struggle with macros. I am not very experienced with macros. I don't really use them very much. So yeah. What's up, Shubham? What kind of magic be? What kind of magic be? Okay, so making very slow progress, but I think we're kind of getting somewhere towards our goal of handling a divide exception, basically. We have this thing. Okay, 20-second break. Stand up and stretch, get some water. All right, this is kind of exciting actually. All right, so you find the Pomodoro helps you focus more. It's more just for, I guess, like physical health than Pomodoro, because this isn't really Pomodoro because I'm not taking like the 5-minute breaks or anything like that. It's just more of like a 20-second thing to, like, you know, look out the window, stretch a little bit. So yeah, and I find that 20 seconds is not long enough to distract me also. So just a nice thing to keep physically moving. Shubham, thank you for the subscription, man. Appreciate that. All right, let's keep it moving. Let's keep it moving. What's next? So I think I need to write that assembly now, which is kind of scary. So you'll need to add an entry point for each trap. Okay, it did that. You'll need to modify to initialize the IDT to point to each of these entry points. Did that for the first one, and you'll have to provide all traps which the trap handler macros refer to, which I have not done yet. I think that's what I need to do now. So your all trap should push values that make the stack look like a struct trap frame. Load GD and KD into DS and ESS. Excuse me. Or DS and what? And ES. I don't really know what's up with the ES thing here, actually. System calls, no. Okay, yeah, nope. It's not referenced, so I'm just gonna blindly do that without understanding it. Yeah, DS. So I think it was like here. Bad segment, interesting. But basically this is kind of what I just need to know. How do you set something into a segment? You use a move W, apparently. So I am just going to give this a try. Okay. But did I? I'm kind of getting my Intel and assembly and Intel and AT&T syntax confused. I actually totally forget. No, medium, okay. In Intel syntax, the destination comes before the source, so things like move to the left. Right. In anti-sync. Yeah, okay. The source. Okay, so I was doing it right. So things move to the right in AT&T, which I'm using right now for some reason. So now is like the most interesting part of this whole thing. Push values to make the stack look like a struct trap frame. I might need some guidance on how to do this. Consider using the push AL instruction. It fits nicely with the layout of struct trap frame. So, trap frame. So what is trap frame? Trap frame is, yeah, it's like the structure that describes register context, a bunch of, yeah, see these ES and DS segment selector things, a trap number, and a bunch of other stuff. What I'm not sure of is what the stack looks like, because when the interrupt or exception happens, I believe the CPU already pushes a bunch of stuff onto a stack. I think that's actually illustrated here. The exception stack, quote unquote. And it pushes a bunch of stuff already. So I don't need to care about pushing like the error code or the or I don't even know what the EIP really is actually. Like what are, yeah, I need to learn actually what this is. I can come back here. Okay, let's say processor is executing code in user environment, encounters a divide instruction, which is exactly what we're going to do. It switches the stack to the one in the TSS to kind of start operating more in kernel mode. And it pushes a bunch of things onto the kernel stack which is what is described here in this exception stack with privilege level change, because we are having one if we're going from user environment, right? So SS, ESP, E flags, old CS, old EIP. So I guess the old EIP is the one that user space was running in when the exception happened, maybe. And then maybe an error code, or maybe not. I still kind of don't remember. So divide error does not have an error code. And how would, like, yeah, where would I find that in the official documentation? Exception error code, none. Okay. Is this like a seg fault? This is close, but not exactly a seg fault. Seg faults are, I think they're usually general protection exceptions. But that's a little bit of a low level detail, but like, yeah, it's like, it's a similar type of thing, but the divided error is just a different type of exception, but they're both exceptions. So yeah, if you were to go into the manual and start reading about like the virtual memory and stuff, where do they even talk about this? I guess protection or pointer validation. Somewhere in either chapter 5 or chapter 4, they're going to talk about how like the checks work, like, or like what happens when you try to access memory that's not like mapped. Page all exception. And then somewhere in there, it's going to say, if this thing happens, we're going to raise a GP exception. Then you go here and you're like, okay, what's a GP exception? You're like, okay, cool. And then, yeah, probably somewhere else in the manual, or maybe it's just here, it's saying if there's a division by 0, triggers a DE exception. So no saved instruction. So it tells us here, the saved contents of CS and IP point to the instruction that generated the exception. Okay. So strictly speaking, this is what the processor pushes on the stack. And then in our code, we kind of pick up where that left off, and specifically with this trap handler no EC, we push 2 more things actually, which is kind of interesting. I see. So yeah, going back. So the CPU did not push an error code, so we push one, and then we push the number, which is received by all traps as an argument. So we probably need to pop that actually. I don't remember reading that, but because now we need to make the stack look like a struct trap frame, but our custom pushal num thing is like in the middle. So we need to get rid of that, actually, I think. So, yeah, what, so I need to be super careful, I think. I can't just write to registers, because currently all the registers are frozen in the state from the user program, I think. Although with this kind of exception, the program is going to die, so it doesn't really matter if we like clobber those, but we probably don't want to clobber them. I'm actually a bit at a loss. Oh wait, but trap number, I see. Oh, okay, no, I see. So I'm just gonna visualize this to help make it a bit clearer. Oh, we already have our trap frame illustration. I'm gonna get rid of this thing. I'm gonna make a copy over here. So we have our trap frame. And actually, yeah, no. So remember that, yeah, I'm just gonna start from scratch. So remember that, let's say this is, let's say, where is it? Where's my arrow? So let's say this was the stack pointer. This is the stack pointer before the exception occurred on the kernel stack or whatever. We have these CPU pushed automatic, like data automatically pushed by CPU. That's the first thing. And then so, I guess I'll make this text a little bit smaller. So, and that's what this is. This is our automatic data. I'm also just going to copy our trap frame reference because it'll be useful. And the confusing part, well, maybe I'll get to that a little bit later. But so step one, CPU pushes a bunch of automatic data onto the thing. And it's going to look exactly like this. And then, then we manually push trap number. So that's number 2, and that specifically happens right here. So that's going to be another thing pushed onto the stack. And so this is the state of the stack. Basically, what's confusing here is that we're trying to construct this struct on the stack, basically. What's confusing, I'm going to flip it upside down, because that is actually a bit more helpful to understand how this like visually like aligned. It's actually, yeah, I mean, I'm gonna make another copy and flip it regular to help read it. But basically all this stuff at the bottom of the struct corresponds to all the stuff that's automatically pushed. Yeah, I'm trying to think of the best way to explain this. But basically all these things are automatically pushed, including, I think, the trap frame number, and it says, or the trap number even comes next. And so all we need to do is push these, like these things above the trap number. Yeah. And then that will have successfully recreated the trap frame. So we need to push a 0, which I don't like. I kind of don't even know how to do this, but we need to push. Yeah, this is like, sorry, it's like kind of hard to understand, but basically there's just a discrepancy in kind of like our diagram. Basically, like offset 0 is here in the trap frame, and it kind of grows up. But yeah, in memory, like memory grows up in this screenshot. Like the struct members at the end of the trap frame are going to live at higher addresses than at the start. So it's like a little bit backwards. Yeah. And then in this diagram, like this is also, yeah. So basically this is just flipping it around to more accurately depict how it is in memory. Basically, we just need to push some, this padding, the DS, the padding, the ES, and then all the registers, which I'm going to try to do. I might yeah, whatever. So, is push W something? Push long is 32-bit, I think. To push 16-bit. Push a word. Or maybe just the normal. I want to push an immediate 16. All right, I'm going to ask ChatGPT. Oh, it just knows. Interesting. Push. In 16-bit mode, you can just directly, 15-second break. Yo, hey, Mukilan. Yeah, that's exactly right. I'm trying to work on this kernel. So right. If you're in 16-bit mode, you can just directly do a push, blah, 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 blah. We're not there, we're in 32-bit mode. So we need to do a push word or whatever. I'm just gonna bravely try to do this push W. Does this work? Make. Yes, that seems to have worked. Yes, so I'm just verifying the assembly of the kernel, and it seems like the push W worked, and actually I'm a little bit surprised to see a 66 here because I don't see a 66. So I don't know, but whatever, I guess. So what is it? Push some padding, then push the DS. How do I push? Does that work? push ds 1e. Is that anywhere here? 1e push ds, actually, right, yeah. That's crazy. So there's all these custom opcodes for pushing segment descriptor, segment registers, which is interesting. So push ds. Then we're gonna do the exact same, we're gonna do the exact same thing, push es. And we're just building more. Or wait, no, I think, am I, no, I think I'm right, yeah. We have this whole thing built up. Like I'm like turning my head upside down to like kind of get a sense of like, oh, this whole thing is pushed onto the stack. And we're just pushing more and more and more, like in a reverse order, basically. And then the last thing is to push the push reds, which is just like all of the registers, which it was giving me a hint to do. Like, it's giving me a hint that you can use the push AL instruction, which I kind of don't really know. Push AL, or push AL instruction. Push A. Okay. But that is, boy, yeah, why is that not, why is that mentioned? Here, get rid of this, get rid of this. Why is that mentioned here and like nowhere else on the internet? Push A. University of Auckland, UNC. Okay, we're at that stage of development where we are looking at university PowerPoints. Push address long. Push pop big 7 registers at once. But why is that not documented? Okay, time to zoom over to the oh, what is this only? Do I not have the general? Wow, why is this so long? I'm not seeing the section of the manual I was looking for, actually. I think maybe this is the one. Yeah, instructions I reference. Trying to get the push. Come on. Push all general purpose registers. Okay, I'm just gonna take a screenshot of this to capture that. For good measure, I'll just take a screenshot of this too. So 1, 2, 3, 4, 5, 6, 7, 8. But yeah. Is that what it says here? Pushes the context, or put the contents. So if, but yeah, the current size is 16. pushes on the stack in the following order. So EAX, ECX, EDX. That means EAX will be at the top, and it'll keep going down, down until EDI, which is exactly what we see here, basically. EAX will be at the top and then all the way down too. So in theory, I could do like a push AD, maybe? That's like the instruction I'm seeing in the manual. For some reason, they were saying push AL. No instruction, push AD. What? How is that possible? Okay, guys, I guess something is going on where push AL is really the instruction. And what happens if I disassemble? And it's just a push A, hex 60. What? And it's just a push A in the end. Interesting. It must be some weird push AD. What was the error again? I just want to Google that just to see what other people are saying, because someone must have run into that on the internet before. Yeah, what's oh, you know it's good when the blog post is in Chinese. Stuff you don't need to know. All right, I'm tempted. Push AD. No instruction. GCC uses, while push AD and pop AD are Intel convention. What? That is crazy. Okay. So I'm using, apparently the syntax type determines, influences the actual instruction names you can use, which is so confusing. I'm just gonna save this link also, just for fun. It's a long link, all right. So actually this is pretty exciting though, because I think that is it. I think that mostly does it then. So now we have our all traps function. Yeah, which I think successfully constructs a trap frame. Yeah, so this looks pretty good to me. So now what do I do? So that was actually faster than I thought. Now I think we're actually ready to try running our div by zero program and seeing what happens. But before I do that, I just want to go look at what this trap function actually does. Breeze through it, yeah, thank you. Yeah, trap. What does it do? So now we enter C code, and wow, okay, I don't know, some interrupts thing. Check that interrupts are disabled. If this assertion fails, do not be tempted to fix it by inserting a CLI in the interrupt path. It's funny. So what, basically, I don't know if I'm allowed to panic here, but made it to the trap function. Okay. Because I don't actually want to really execute it. I just for the purposes of my test, it would be awesome if that happened. And I guess now I need to go back to the init thing. So actually, I don't want to run the hello anymore. I want to run the user div. Is that even like what is user hello? Oh, what? How does this work? Oh, it's like, oh, binary obj or whatever. Okay, so binary obj or how does that work again? Or hello? User hello. I'm trying to look at this make file. No, I think I need to look at the linker. Oops. Command. Okay. If I look at the linker command, it will show me something. Yes. So, hello. I think the better way to actually do this is just, the more pro way to do this is to do a, probably like a, yeah, readelf is my go-to for, kernel. And then, yeah, now we can see all these symbols. And now we can get the div. So this is what they are. User div 0 is what that looks like. So that's what we need to pass into here. Right? User div 0. So in theory, now that should be causing us to load the div 0 binary as the init process. And what does div 0 do? It tries to print out a division by 0. Cool. Okay. So now, yeah, is that it? Is that it? I'm just gonna compile it. Why was that so slow? That was such a slow compile. Or maybe it looked that way because I have my yeah, that's better. All right, let's run it. Moment of truth. All right, it didn't work. It's panicking. Whoa. Okay, or it's not panicking. It is rebooting. So I guess it's time to debug it somehow. Not totally sure how to do that, but probably the I don't know. I mean, yeah, let's just debug it. Trap init first off. I'm also going to break points on I guess I would like to break point on the the first instruction of the div by 0 thing, or which Okay, day 0. Yeah, that's so, oh, I just tried to run it. That's so handy that the build system here automatically produces these assembly listings. So yeah, but this is the hard-coded, or not hard-coded, but like this is just the first instruction of the binaries we produce. I guess I could even break here. Continue. And I'm just going to keep going. So now we're actually here. Oh. Wow. Interesting. So step I, step I, step I. So what is this? What is this? Basically, wait a sec. Does it even do a divide? Are you seeing a divide anywhere? Push, move, sub, move, push, push, call. There's no divide anywhere there. So that would explain why it didn't work. I always have such bad luck with this stuff, but user see, because I have this ongoing issue where I cannot disable optimizations in the kernel, which I've yet to debug. But I wonder if I can disable optimizations for user space. What happens if I do O0? Does that change anything? Oh, okay. Oops, sorry. Okay. Make. Oh, so that compiled. So now let's take a look. I don't know about you guys, but this looks a lot less optimized to me. I'm still looking for the division though. I don't see it. All right, 20-second break. Checking the chat. Yo, what's yo, Makita. Thank you for the compliment. I've been coding for like 10 years. How many hours on average? No idea, but I have spent a lot of the past 10 years programming. And yeah, doing programming related stuff like reading assembly and whatever. So that's kind of how I have this skill set. Yeah, Ismail, like, I'm pretty sure it's just a div. Yeah, it might be some toolchain stuff. Like maybe the version of GCC I'm using is newer than the one they were using in 2018, which is like very possible. And maybe the toolchain is emitting different code than it previously used to. That's annoying. I actually don't really understand this code though. This is like a little bit. Yeah. Do we have any average dude are able to reach your level? Yeah, totally, man. I'm not that smart. I've just been doing this for a long time. Not OS programming, but like computers and stuff. Yeah, I used to work in the cybersecurity industry, where I learned a lot of these skills with like reading assembly and stuff like that. So I think it's definitely possible. Yeah. And my recommendation for you, Makita, I'm a huge fan of this website called pwn.college. And if you're interested in being able to like do stuff like this, I would highly recommend following the exercises there. Yo, what's up, Simon? Kimu i386. I chose i386 because I know x86 already, and it's also the most documented for doing kernel development. Like, there's like so many blog posts and documentation for x86 kernels. So that's why I'm using it. All right, I don't see the division by 0 here, so I'm just gonna add it myself. Div 0. With, I guess, some inline assembly. I'm actually not totally sure how to do that. How would I write an inline assembly? Okay, that's scary. That's scary. It would be so nice to not have to do that. Or actually, I mean, maybe I am jumping the gun though. Maybe actually, okay, no, it didn't do it. I'm just gonna ask ChatGPT. Please write for me some inline GCC AT&T assembly that does a simple division by 0. Can be dangerous. Holy crap. Yeah, that's... Wow. Oh man, sorry, my chat bot was a bit aggressive with the moderation. Sorry for that. But yeah, saw the comment. Yeah, I mean, you can definitely get there. I'm just gonna repost. Yeah, I mean, game dev is also a good industry to have these skills. Like, these skills are all very relevant for game dev, for certain kinds of game dev work, I think. Okay. So in theory, this is our divide by 0. Let's verify. And yeah, I don't really get it, but we see an idiv, so let's run it up. Make kimu, please. Okay, still didn't work, but at least we're closer. So quit anyway. The just gonna break directly on this thing. So, I mean, yeah, I don't actually understand how division works really with assembly. I haven't had to read very much assembly that used divisions, so. EBX. CDQ. This is so esoteric. So EBX definitely has 0 in it. So so what do we expect to happen? So the idiv is going to trigger a division by 0, I think, which that should cause us to go into execution of like it's going to cause a bunch of automatic interrupt machinery to basically get triggered. I'm just going to do a step instruction. Oh, crazy. That actually worked. Kind of. Wow, that's awesome. That is sick. Okay. I was totally expecting it to like reboot or something like that, but actually we have officially entered our trap handler, which is sick. Can I get what is it? Some W's in the chat? What do I say now? Yeah. So that means it's actually kind of working a bit more than I thought. Oh, thank you very much, YL. I'm using VS Code and my terminal with tmux. Thank you for the W's, everybody. Thank you. All right, let's check this out. Can we disassemble? All right, so now we're stepping through the handler so we can see a push, and a jump. And that's exactly what we are seeing here. So that's this thing, push 0. So when we have no error code, the macro just pushes kind of a placeholder 0 in place of it to keep the kind of like the struct layout equivalent between the case where there is an error code with the trap handler and when there isn't an error code. So we put push 0, then the push of the trap number, in our case, divide error is interrupt 0, and we have the jump. So let's step through that. So now we jump to all traps, and we I think I might know what the problem is. It might be that we actually do get, okay, never mind. Okay, that was I don't know, push W just failed and we rebooted the machine. So our handler is messed up. So specifically here, we're not able to push things onto the stack for some reason. And I'm not totally sure. I'm gonna drink some water. Not totally sure. Yeah, I don't have the strongest understanding of what really happened to the stack just now. Like when we transitioned from user space into the kernel, a bunch of like automatic stuff happens related to this TSS segment and the task state segment and whatever. So I'm not totally sure, but we can debug a little bit. Yeah, let's do that. Let's do that one more time. That was kind of fun to see. All right, GDB break on this thing. Continue step instruction. Right? Yep. Okay. Step instruction. Push, jump. Okay, here we are. So let's take a look at what our stack pointer is. EFFF, what? I'm just gonna take a screenshot just for debugging. So we do have a stack pointer. Something is just wrong with it. Yeah, I'm gonna keep going for a little bit longer, but eventually I do need to leave. Seeing this makes me think Linux kernel might not be that obscure. Yeah, this is, yeah. The Linux kernel gets a bad rap, but sometimes this stuff is just kind of gnarly. So, we talk about it here. Task state segment. This thing is important somehow. Let's read this. The processor needs a place to save the old processor state before the interrupt or exception occurred, such as the EIP values. Yeah, such that it can restore the state. But this save area must be protected. Okay, so when it takes an interrupt or trap that causes a change, it switches stacks to a kernel stack or something. A structure called the task state segment specifies the segment selector and address where the stack lives. Okay. Let's just stop there and take a look at the code. So we have, where is this again? Trap.c, trap init. And init trap per CPU. So this is where it happens. So remember the GDT has this TSS entry. Which that entry is not itself a TSS, it's like a pointer to a TSS. This TS thing is the actual TSS, task state, I think. And it's interesting. So who initializes the T, like, did I forget to do that? Maybe. Maybe I forgot to do that. Does it say anything about stack? Values. So I like that's where I'm crashing. I can't even push any values. So who is referencing this TS thing? Here. That's pretty much it, actually. Oh, and it's literally right there. Okay. And it's comment, set up a TSS so that we get the right stack when we trap to the kernel. Okay. K stack top. Kern base. So what was that address again? It's EFFF. So it's like, it's, maybe this math is kind of easy, but I'm just gonna do it this way. It's 28 bytes. Ooh, wow. X1C. Is this visible? Okay, yeah, just barely visible in the. So 28 bytes. That sounds wrong, or I don't know. So in the code, we're instructing the CPU. We're saying, hey, when something like when the interrupt happens, switch to K stack top or something like that. I actually am not totally sure how. Oh, maybe it's this, the LTR. Maybe this is what communicates it. So we have our task state. We have our pointer in the GTT to the task state, and then we formally say, hey, CP, with the LTR instruction, here is the segment selector for the pointer to the task state. And then I think then somehow when the CPU needs to make decisions about this, it like references the TR maybe, then finds the entry, then finds the TSS. Maybe I don't totally get that. But we're basically saying switch to this stack when we trap. So I just want to test that. I mean, we could just we could also kind of reason about it more directly, or more indirectly, but I'm just going to debug it again. Be this thing, continue SI, and we're here. And what is the stack? It's already like super low. Oh, but wait, that kind of makes sense though, because there was a bunch of stuff that was pushed. All right, 15 seconds. So maybe that makes sense. So what is EC? It's probably just 20. So I guess maybe that makes sense. So the interrupt happens. it switches stacks to like this kernel stack that starts at k stack top, which is like some big number or something. And then it pushes a bunch of things, which we were looking at over here. So it pushes these things. 1, 2, 3, 4, 5. Yeah. Wait, also, wait, what? Yeah. It was able to push these things onto the stack, I think. So something is strange then. Oh, wait. Or, no, I just want... Let me just do... Can I do 20? Exactly? That's 20 words. I want 20... I want just, I want 5, I think. So EIP, right. Yeah, so check this out. This is pretty cool, actually. I'm gonna take a screenshot just for tourism purposes, taking some pictures of our trip. Okay, so this is kind of cool, actually, because you can see, we can actually see the, or what am I doing? We can see, we can really see this. So the first thing on the bottom of the stack is the EIP. That's this 8054, which is actually the EIP of that IDIF instruction. So that's pretty cool to just see that. All right, see you, Ismail. That's pretty cool to see. Then there's the 1B, which is the code seg, or the CS register, which I'm going to the GDK. No, it's like UT, I think, is hex 1.8, the user text segment. So that's kind of neat. Then there's the 86. What's that? The E flags. Okay. Then there's the ESP, which is this thing is EE something something something. Is that right? Memory layout? That looks about right. EE BFD something something. EEBF. Yes, so that looks correct also. Then there is the some 23 number. Which is the stack selector. The stack selector. I actually don't really know that so well. Where is the stack selector coming from? Let's see. Can I just search for a hex 23 somewhere? No. Okay. All right, that's like a little bit of a mystery. Software is hard. Yep, Mike. That's. I would agree. Hey man, thanks for showing up. I don't know how to pronounce your name. Also, is that an ant? I'm just gonna call you Ant Guy until I know how to pronounce your name. But thanks a lot for showing up again. I need to end this stream relatively soon. Interesting. But I don't see a 23. Could that? Shinobi of the Abyss. What should I learn to learn all this stuff? I'm gonna link you a couple things. I'm gonna send you to my resources, and I'm gonna specifically send you to pwn.college. That's what you should, specifically pwn.college. I think that's one of the best places to get going and do all this stuff. Yeah. So that's interesting though. Like so the pushes worked. So what is going on then? But yeah, like also those pushes right there just worked too. And all we're doing is jumping. Is push W the wrong instruction? It might be the wrong instruction. But actually, wait a sec. That is actually very interesting because no, what am I doing? Because push long. That is so interesting that it's okay to do these pushes and those seem to totally work. But then as soon as we get here, we cannot push anymore. I wonder, just for fun, what would happen if I just pushed the DS? I don't know, like I'm a bit suspicious about this push W thing. Can I? Interesting. I wonder if this will work. Yeah, that's crazy. That's very cool. I just set a breakpoint directly on the divide interrupt handler. So this stuff is totally working. Jump. And now we're here. And I'm going to look at the stack pointer, which seems pretty legit to me. I'm going to dump the stack so we can see a couple things. We can see the EIP, we can see the 2 pushed zeros. So that all worked. So now what happens when I do the push DS? That worked, right? That worked. So that just means that I don't like, yeah, push W is not working. So what does do? That's what I thought. That's totally what I thought. Is it trying to do reference? That somehow? I'm a little bit at a loss actually, but I also need to be a bit careful, I think, of the alignment here. It looks like the push, oh, it looks like the push DS automatically did some padding, I think. So it might not be even necessary to do these explicit padded zeros, although it's still a mystery to me why. I'm just gonna try this just for fun. So push 0, does that, also, what does the stack look like just for starters? It's a bit too much. So here's our stack. Push 0. Something about Oh, is this? Oh, oops. Wow. Oops. Okay. So something Oh, okay, yeah, that's it. We can see that there's just something different here. And actually, so here's the code that works. It has these dollar signs. And here's my broken code without the dollar signs, which means, I think, that if you just have a direct address, at least with AT&T syntax, it like interprets that as like a dereference, like a pointer, saying like, please push the dereference of that hex number, which is not what I want. So actually, like if I wanted to push some constants, you need to have it's the dollar sign. So just for some closure here, I guess I'm just going to run this through, and so now it's P, and then now we push the 0, we push the 1, we check the stack, and we can see a 0 and a 1 there. So that is just me making a dumb mistake. So now what I learned though is that actually with the push DS, it actually, I think, pads it to 32 bits already. Continue, step. All right, let's take a look at our stack. Push a DS. Got the 23. We'll push the ES. Also got the 23. And we're okay. Now this doesn't work. Move. So presumably that didn't work for the same reason. Okay, let's try that one more time. All right, this is exciting. This is kind of cool. We might, oh, what? Oh, instruction prefix. Oh, what? What? Yeah, so that's just a define. So, I wonder, is this just what I need? Oh, this is so annoying. Okay. So it crashed. I'm trying to do this. I think. What if I just, did this and kind of didn't use the variable? Would that work? No. What about this? Operand type mismatch for move. All right, time to how to load a constant into DS and ES for AT and T syntax. I've been trying to not use ChatGPT as much as possible, but yeah, I'm kind of running out of patience for this, so interesting. I guess with move, is that legit? You cannot move a constant directly? Interesting. I have to move it somewhere else first. Or maybe into a 16-bit register. Interesting. So let me just try that. Oh, what? No, I didn't really want all those comments, but okay. So how does this look now? Move 10 into AX. Move EAX into DS, is that right? That's what it did, okay. Step, step, step. Push DS, push ES, push A. Move, 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 push ESP, sick, call, trap. Okay, we made it. We're now in trap. And what happens if I continue? Made it to the trap function. Hell yeah, made it to the trap function. We did it. We did it, guys. That's so sick. Wow, what a journey. So that's significant because it means like the whole interrupt infrastructure is like kind of working. I just added this panic to stop it from continuing to execute, because all I wanted to do is confirm that we kind of get there. So yeah, if you want, feel free to send some W's in the chat to celebrate that occasion. Hey Nirajan, nice to see you again. Wow, that's cool. All right, y'all, I think that's a good place to end the stream. Yeah, thanks a lot for coming. Like, comment, and subscribe if you like what I'm up to. I do this every single week. I'll also post a recap video of this stream where I kind of summarize it in about 10 minutes. I've been doing that for the last couple weeks. And I'll post my Discord. Feel free to join the Discord. And yeah, gonna call it here. Thanks a lot for joining. Have a great week. I'll see you next week. Peace.